Hello everybody, welcome back to another glorious maths video. And this video is part story, part mathematics. You know, get some popcorn, maybe some tissues. It was quite an emotional story. But here we go. It was an exercise in a commutative algebra book PDF I was reading. Exercise 3. And it was to prove the Chinese remainder theorem, and since this is like a theorem that's normally like proven for you in a book, I thought, oh god, scary, you know, like oh, this is gonna be tough. Like, I don't know why it's exercise 3, but you know, it's gonna be tough. Then I went to, oh, this is completely trivial. Then I went back down to, oh shit, this is not completely trivial. So here we go. Firstly, yeah. What is the theorem? I'm assuming a Chinese guy came up with this, since it is called the Chinese remainder theorem. So, let's see what it is. There is an elementary number theory version, but we're going to go for the hardcore commutative algebra stuff. Alright, so let's say we have, this works for finitely many ideals, so A1 up to AN. I'll just work with A1 and A2, since that's sufficient to prove the general case anyway. So, actually no, the theorem looks more scary if I use A1 to AN. But, okay, so let's say we have A1 up until AN. This is my thought process. So yeah, I did use A1 until AN first of all. So let's say we have ideals A1 to AN, such that AI plus AJ equals 1 for I not equal to J. Then, we have that R modded out by the intersection from I equals 1 to N of AI is isomorphic to the product of from I equals 1 to N of R mod AI. So that is R mod A1 times R mod A2, blah 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 blah. Okay, cool. Yes. So right, let me prove this now. Proof. Okay, so firstly, I thought, you know, quotients, blah blah blah, let's use the first isomorphism theorem. Here we go. So, I drew out my diagram, I had my commutative triangle already, so it had R, I had a map phi, which I'll define in a second, which took me to the product from I equals 1 to N of R mod AI. I had this map here, and of course I needed the kernel, I needed this to be surjective, and I also needed the kernel to be the intersection, so for now let's just write R mod the kernel. And we have some unique morphism here. I'll call it phi bar. Now, what's this map phi? Great question. Phi takes in obviously some element R, and I defined it to be R plus A1 up until R plus AN. Now, what's the kernel of this map? The kernel is actually quite easy, and the kernel is in fact the intersection, which was perfect. Off to a great start. The kernel is the intersection, and here's why. So it's somewhat simple reasoning. We need, okay, the kernel is a set of all stuff, so that all of these guys are 0. How do we get this to be 0? Well, R has to be in the ideal A1. Sorry. Okay, great. Now, how does it, in the second slot, how does it become 0? Well, R has to be in the ideal A2. Third slot, A3, blah, 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 blah. So it has to be in all of them, i.e. it has to be the intersection. So, the kernel is the intersection. Perfect. Now, looking at it, you know, obviously it's a surjection. Boom, first isomorphism theorem, finished. Chinese remainder theorem, overhyped. You know, terrible, you know, beautiful theorem, really easy to prove. Let's get on to exercise 4. And as I was scrolling down to go to exercise 4, suddenly I see this. And then I'm thinking, wait a minute, I haven't used this, but I've proven it, so what's going on? Why have they given me this? And then, okay, so I was asking around, like, what the hell is wrong with this proof? Turns out this is not a surjection at all. Turns out I was being really stupid. This is not a surjection. Consider, for example, let's say our field is the integers, and consider the integers mod 2, and the integer's mod 4. Now, our map here wouldn't be a surjection because we would never be able to make the first slot equal to 1 mod 2 and the second slot equal to 0 mod 4, because that would imply that R is R is odd, but somehow R is also divisible by 4. Suddenly something's wrong. So this is not surjective, and it was at that moment that I realised the Chinese remainder theorem, scary as it looks, look at all these intersections and products and scary stuff. All it is saying, this is surjective. Can't be that bad, right? It was pretty bad. Okay, let's simplify. Okay, this is where I simplified to just 2 guys. So I have A1 and A2 now. Okay, so now, what does surjectivity even mean? It means that any person in here, any guy in here, so just some S plus A1 and some Q plus A2. That's just any guy in here. That can be written as R plus A1, R plus A2. Okay, now, so far so good. I can rewrite this. That means that S is equivalent to R mod A1 and Q is equivalent to R mod A2. Great, okay, nice, cool. Yes, so all I need to do is show that these 2 equations have solutions, and somehow that is going to use this fact here. Also, I don't know why I've written 1. I should say R. That was stupid, yeah, should say R. Well, to be fair, that is the ideal generated by... Sorry, I apologise, yeah, that should have said R. Okay, whatever. Right, anyway, so, okay, it was at this moment that I realised I had no idea what to do. And so I asked for help, not for the solution, just like a hint. The hint was, use the fact that 1 is in AI plus AJ. So that is, there are some A1 and A2, so we have A1, sorry, I'll use B because I'm not going to write out a math frac A, so let's say B1 is in A1 and B2 is in A2, such that B1 plus B2 equals 1. Okay, I have that. So I was fiddling around with that, I was plugging it in here and there. Nothing. Nothing. So, you know, half an hour goes by, literally no progress. I'm thinking, how the hell do I solve it? Okay, ask for another hint. And the guy gives me SB1 plus QB2. Let me try that. So I'm immediately thinking, okay, maybe that's just a solution, so let me just plug that in. So what happens then? Then we get S is equivalent to what? SB1 plus QB2 and we have mod A1, Q is equivalent to SB1 plus QB2 mod A2. Okay. Suddenly something was wrong, because it was all going beautifully until I realised something. So I was doing this. I was doing SB1 plus QB2. So mod A1, we can get rid of that. So this is equivalent to QB2. And this is equivalent to it's equivalent to Q. Because you just add on QB1. And suddenly I'm getting S is equivalent to Q, whereas really I should be getting S is equivalent to S. And then I realised the guy had gotten either I had gotten his letters mixed around, or he had gotten his letters mixed around when he was just typing the hint. And it hit me. It actually hit me while I was recording this video, because I hadn't actually finished the proof. I just realised, oh yeah, that'll work out, that'll cancel. I see where it's going now. And then as I was recording the video, I might put this footage in at the end, I was just like getting depressed. I was like, why the hell is this not working? Like, what is going on? Turns out it should just be SB2 plus QB1. And suddenly, the solution becomes SB2 plus QB1, because here we have SB2 plus QB1 is equivalent to SB2, which is equivalent to S mod A1, and similarly we have SB2 plus QB1 is equivalent to QB1 is equivalent to Q mod A2. The solution exists! Yeah! Oh, that hit the roof. Whoops. Yes! Yeah, there you go. Solution exists. This map is surjective. The kernel is still this. First isomorphism theorem holds. Chinese remainder theorem. Done and dusted. Thank you for watching. I hope you enjoy my commentary. I'm back. I figured out why it works. Okay. I didn't. Yes. The trick is here. Yes, I figured out why it works. I didn't. Recalled the right thing, and then I did not recall how to do it. Yes, the thing is, this is yeah, okay, let me just write it out. R is equivalent to SB1 plus QB2, which is equivalent to, now obviously this guy can just go away, so we just get QB2, which is equivalent to QB1 plus QB2, here we go, which is equivalent to Q, because when we factor out the B1 plus B2, we just get Q. Mod A1. The sudden realization is amusing. And I've done it the wrong way around. How the hell is that the wrong way around? It's the wrong way around. That's a little bit depressing. So glad this was recording.